In this lesson, you'll bring in a second SEC dataset to expand the context of the original filing forms. This second set of forms provides information about institutional investment managers and the interests they hold in companies. By adding this data to the graph, you'll be able to ask more complex questions of the combined datasets to help you understand market dynamics. Let's take a look.
You will start in the usual way by importing some libraries, then define some global variables, and of course we need a Neo4j graph instance to connect to the Neo4j database. SEC Form 13 is filed by institutional investment management firms to report what public companies they have invested in. The forms are available as XML files. During data preparation, particular fields were pulled out of the XML and added as a row in a CSV file. To begin, you can read the CSV file in using the csv.dictReader, which will parse each row and turn it into a dictionary using the CSV header row for keys. Let's take a quick look at what the rows look like, though. Maybe just the first 5. Okay, you can see that each of these firms have invested in the same company. If you kind of take a look here at company name, there's NetApp. There's company name NetApp again. All of these management companies have different names, but they're all investors in NetApp. You can see that there are details about the firm itself, things like the manager name, the address of the manager, and also this central index key or CIK key. There's also about the particular, information about the investment that they've made. So what is this reporting calendar? What was the values, the number of shares? That makes sense. Here the value is a monetary value, so this is dollars. You also see some metadata about the company that they invested in, both the QSIP6 code and the QSIP code. Let's see how many rows there are. We'll just check the length. Okay, there's 561 rows. We'll expect 561 companies to be created. Now from each row, you will create 2 nodes, one for the management company and one for the company that they invested in. The management company nodes will have a manager label. They'll be unique based on the central index key from the SEC, and they'll also have a manager name property. The company nodes will have a company label. They will be unique based on the QSIP6 identifier. The company nodes will also get a company name and a full QSIP6 property from the Form 13 data. Let's start by creating the company nodes. Merge in the company nodes with a company label that is unique by the QSIP6 identifier. We see that on creation, we're going to set the company name and then the QSIP number itself. Quick bit of sanity checking. We're going to expect that the company we just created is NetApp. Of course, NetApp is there. Perfect. You already have a Form 10K form for NetApp in the knowledge graph. You can match the newly created company node to the related Form 10K by finding the pair based on the QSIP6 identifier. So that's what we're doing here. We're just matching a pair of nodes, a company and a form, where the QSIP6 is the same in both of those. And then we're going to just return those 2 nodes. You can run that match again, but now because we've noticed that if you take a look here, the form names, the names of the company from the form, show not only that it's NetApp Inc., but also some variations on the name. We can take those values and pull them over to the company node to enrich it. So we'll do the same match based on the QSIP6, and then once we've got that, we'll set the company.names to the form.names. And we'll take one more step. With that same pairing from company to form, we're actually now going to create a relationship so that we know this company filed this form. The investment manager nodes will have a manager label. Let's create those next. We've got, a manager with a manager label. We want it to be unique based on the manager CIK number. When we're creating that, we're going to set the manager name and the manager address. As before, we'll pass in a dictionary to the manager parameter. That'll be the query parameter that is used inside of this query to create these nodes. We're going to do this first, just for the first Form 13. Then a quick sanity check to make sure we've done the right thing. And there's the manager node. We've got the name, Royal Bank of Canada, their address. Looks good. There will be many management companies, up to 561, right? So let's create a uniqueness constraint to avoid creating duplicates accidentally. Also, we can create a full text index on the manager nodes. The full text index is useful for keyword search. If you think about a vector index, that allows you doing searching based on similar concepts. A full text index allows searching based on similar looking strings. You can try out directly querying the full text index the same way that you can directly query the vector index. Here we're going to look for Royal Bank. That query will return a node and a score, very much like what happens with the vector search. If that matches, we'll find the node manager name and then also the score. So both Royal and Bank ended up finding some good matches here. But the top match, the best match, of course, was Royal Bank of Canada. Now you're ready to create nodes for all management firms that appear in the CSV file. Just use Python to loop through all the rows. So here in params, we've got manager param set to whatever form 13 is. We know that's a dictionary because all form 13s is a list of dictionaries. Again, sanity checking is always a good idea. So we'll just go ahead and match for all managers and return a count of those managers. We're expecting 561. Perfect. You can now find pairs of manager nodes and company nodes using information from the Form 13 CSV. You can see in this query that we're going to pass in a query parameter called investment parameter. And in the match, we're going to match for the investment parameter manager CIK. And then to find the company in that same rel, we're going to find the investment parameter Q sub 6. So this match will find, based on those two values, a manager and a company that match that row. Cool. If you remember our first row, it was Royal Bank of Canada. Of course, they invested in NetApp, so this all looks correct. You can find a manager node and the company they invested in. That's great. You can now connect those nodes together. This is something you've done before in the course, but the query will get a little long, so let's go through it one line at a time. So we're going to create some cipher. So let's say cipher equals triple quotes. And the first line we want is the exact same match we had before. So now we have a manager and the related company that they've invested in. And so we want to create a relationship between them. So we're going to use a merge. We'll merge from that manager through a own stock in relationship over to the company. And we want the own stock in to be unique in case they've had multiple investments. And if you recall, looking back at that CSV file, some of the rows had a report calendar or quarter value. Let's use that as a unique property on the own stock in relationship we're about to create. The property will be called report calendar or quarter. And we're going to grab that from the query parameter. Okay. And now you've seen this before. This is on create. So when the relationship is created, we're also going to create these extra values. And then finally, we're going to return a couple of properties from both the manager, that relationship that was created, and the name of the company. Okay, let's close that out. And when we call this with KG query, the parameter that's going to get passed in is called owns param. That's what we've used throughout here. And we're going to use just form 13 for now, the first form 13. Okay, before we run this, it looks like I've missed one thing. Here on the relationship that is newly merged in, we're setting the value in the shares, but we're using this owns variable, but we haven't actually used that up here to set the variable. When it's created, we want this to be the owns. Okay, I think this looks right now. Let's give it a go. Our good friend Royal Bank of Canada and NetApp. Awesome. Okay, we'll just run a quick query to sanity check again, make sure that the relationship actually exists. We'll grab the relationship here in the pattern, and then we'll look from the owns relationship. Let's return the shares and the value. Cool. Having done that once, you can now loop through all the rows of the CSV file to create an own stock and relationship between a management company and the company they invested in. Of course, that company will be NetApp. Now, this is the same what you've done before. We're just looping through, creating all the merge statements to create the relationships. Another quick check to make sure that we did the right thing. We're expecting that we have 561 relationships created. Perfect. We have changed the knowledge graph quite a bit from when we first started. We started with just chunks of the form 10Ks, then we connected those chunks, and we created a form that the chunks would be connected to. And now we've created companies and managers, all of that's been connected. Let's take a look at the schema of the knowledge graph to get an idea of like what all of our work has produced. We can do that by refreshing the schema on the knowledge graph and then just printing out that schema. We'll take advantage of text wrap here to try to get some good formatting. Okay, first the nodes that we've got inside of the knowledge graph. you can see that we've got a chunk node with its properties. And over here, there's the form node, properties for that. There's the manager that we created, the company we created, and all those properties. That's awesome. The bottom half is relationships. And we can go down to here and see we've got from a chunk is a part of a form. That's correct. We know that chunks have a next to other chunks. That's the linked list of chunks. That's awesome. And also you can go from the form through a section to a chunk. That's how we found the beginning of the linked list, right? Finally, we've got that the manager owns stock in a company and that the company has filed a form. All that together ends up being the knowledge graph we just created. What I love about graphs is that they are awesome for exploration. Let's have some fun looking around to see what we can find. To begin, find a random chunk to use in later queries. So we're just going to match for chunks and return the first chunk ID as chunk ID and limit it to 1. This is whatever chunk happens to be the first one that we find. So when we run this query, we'll save that in chunk rows and print out chunk rows. Cool, there's our chunk ID. Well, let's store that so we can use it later. You can see that's a list with a dictionary inside. So first, let's grab things out of the list. So now we have just the dictionary inside. From that chunk first row, we'll grab the chunk ID and store that in ref chunk ID for later queries. So we'll start to build up a path from that chunk that we know about back through a form to other things that we can discover one step at a time to see what's possible. So the first part, of course, is we're going to go from that chunk that we know the chunk ID of, and then go through the part of relationship to the form that it's a part of, and return that form source. Okay, that's good. We'll take one more step here, and in this pattern, we're going to actually break it up into 2 lines. So it's a chunk that is a part of a form where that form was filed by a company, if you read that second part backwards. And we're going to return the company name. As you'd expect, it's our good friend NetApp. Okay, we're going to extend that yet one more step. Here we're going to go from the chunk that's a part of a form where a company filed that F form, and then there's a manager or management investment company that owns stock in that com. Okay, the com is the company here. All these variables have to match up. This is one big pattern broken up into 3 sections. We'll return the company name and a count of how many managers, as we'll call it the number of investors, invested in that company. This is great validation, okay? Of course, the company is NetApp, and we know, as expected, there's 561 investors in that company. We've done good work. You're starting to see some of the fun things that are possible with the knowledge graph. Fun and actually useful. This is information that wouldn't be possible with just a vector search. That pattern you just created, from a chunk all the way to an investor, is useful information. You can use that information for expanding the context provided to an LLM. For example, you can find investors for a company, then create sentences that contain details about each investment to further extend the information provided to the LLM. You'll use the same match you had before, the same pattern, and then instead of just returning data from that, we'll take some of that data and then turn it into a string sentence. Here at the bottom, you can notice 2 extra things. This is just concatenating strings together, but then here, we're taking the value, and we want to have that be nicely formatted. We know that that represents dollars. So we're going to turn that into an integer, and then format that integer using epoch number format. That's going to add some commas to improve readability. Let's save that into results and see if we can pull out the sentences so you can read them a bit better. Okay, looking at just the first sentence we created, you can see that this fund named company owns a lot of shares of NetApp at a value of, well, gosh, quite a lot as well. You see the kinds of things you can do with pattern matching and turning the values from those patterns into sentences. Let's put that to work inside of a RAG workflow. We'll set up 2 different LangChain chains, as we did before. One will be just a regular vector lookup, and then we'll do another one that's going to have a retrieval query to grab extra information. We'll test them both out on some questions. The first chain that we'll call plain chain, this will be the one that doesn't have anything other than the strict vector search. And then we're going to define a cipher query that we want to extend a vector search with. So we're going to call it the investment retrieval query. This pattern should look familiar at this point. From a particular node, remember this will come from the vector search. It'll give us a node that it found that is similar to the question that was asked. We're going to go from that node, know that it's part of a form. From the form, we know that it was filed by some company. There's a manager who owns stock in that company. The arrows are pointing the other direction, so you got to read those backwards this time. Okay, from the original node, we're also going to take the score, the manager, the owns relationship, and then the company. We're going to order all of that by the investment shares, descending and just limit it to 10. Then we're going to basically create one giant text out of all that, collecting everything together into some statements, and then prepending that to the text we return from the vector search. As in previous lessons, we'll create a new vector store, but now using that extended query. Here, the retrieval query is going to be the investment retrieval query we just defined. We'll create a retriever from that and then a chain. We'll call it investment chain. Now we're ready to try a couple different questions. Let's start with an obvious one, since we know this is all about NetApp. So let's have a question that says, okay, in a single sentence, tell me about NetApp. So we'll use the plain chain that we just defined, which is the one that just does the vector search. We'll run that first. You can see that here, NetApp is a global-led cloud company. Yeah, this all makes sense. Let's try the same thing with the investment chain. Let's see if that extra context changes a summary about what NetApp does. So that actually looks pretty similar, which isn't unexpected. The LLM ignored the extra information about investments because we didn't really ask about that. So what if we did ask it about the investors? So in a single sentence, tell me about NetApp investors. Again, we'll go ahead and start with plain chain. That's only going to do the vector search and see what answer we get. Okay, it thinks that the investors are a diversified customer base. Okay, just kind of putting things together here, trying to come up with some kind of an answer. So now we'll try that same question, but with the investment chain and see what we get. Okay, this is a bit more realistic. Now we can see that the investors include KBC Group, some treasurer, Cambridge Investments. This is great. This is actually a great place to start tinkering around a little bit. You can change a couple of different things. You can change the sentences that we're creating out of the investments, see how that impacts what things you get, change the question that you're asking here at the end, and see how different prompts actually adjust what you get out of the LLM. There's a bit of an art still involved in getting the LLM to understand the information you're giving it and how that relates to questions that actually can be answered and how they can be answered. We'll explore a lot more of that in lesson 7, so let's go to that next.